Again, everybody. In this video, we're going to look at what we call group transfer reactions. Remember when we looked at a couple of functional groups called esters and amides earlier. Now, just as a reminder of what esters and amides are, remember that an ester has our carboxylic acid group. And then from there, that carbon is attached to another oxygen, and then with something else for an R group coming off of that. So those are our esters. And amides have our same carbonyl group, but then instead of coming down to an oxygen, they come down to a nitrogen with either different R groups or even hydrogens. Or even hydrogens coming off of that. Esters and amides are called carboxylic acid derivatives because they can be prepared from carboxylic acids by the transfer of what we call the acyl group. The acyl group is the carbonyl group, so the C double bond O, and whatever the attached R group is. And so in our examples here, the acyl groups, which will eventually be transferred, are those portions right here. And those portions can be transferred from the carboxylic acid. So here's our acyl group, which can then be used to prepare esters or amides, depending on what we react it with. This transfer then, again, will produce either an ester, a thioester, or an amide. We actually technically didn't talk about thioesters. The thioesters are identical to esters with the exception of the oxygen is actually going to be a sulfur. And so a thioester would look the same, but we'd have a sulfur atom there. And so that's a thioester. Everything that we talk about with esters in this video can be applied to thioesters. You would just replace the oxygen with a sulfur. Other than that, it would be the identical process. And so we have this acyl group here from a carboxylic acid, which can then be reacted with various compounds, which we're going to talk about, in order to produce our esters, thioesters, or amides, in order to make these important compounds. Within biological systems, there are enzymes that are used called transferase enzymes, which facilitate these reactions. So let's take a look at them. So here in the top one, we have a reaction called esterification. Just means that we're making an ester, we're forming an ester. And we're going to do that by taking a carboxylic acid, could be any carboxylic acid, doesn't matter what this R group is, but we're going to take a carboxylic acid and we're going to take an alcohol, either a primary or a secondary alcohol. What's going to happen then is the OH that's on the carboxylic acid and the H that's on the alcohol, those are going to be removed from their respective compounds, and those are going to come together to form water. We can see that happening here. And so this OH and this H are going to come off the compounds to form water, and we're then going to form a new bond. The carbonyl carbon here is going to attach itself onto the oxygen. And so this is the new bond that's formed right here. Again, from this carbonyl carbon onto the oxygen in order to form our ester. Whatever else was attached to the carboxylic acid, whatever this R group was, and whatever else was attached onto the alcohol, whatever this R group was, those are just going to come along for the ride. Nothing else is going to happen on those. Nothing's going to change on those. Those, come along for the ride, and we form the ester based on that. A thioester, remember the same exact thing, except now instead of the oxygen from an alcohol, we have a sulfur from the thiol to form a thioester. Amidation, the forming of an amide, the exact same process, only now we're going to take our carboxylic acid and react that with an amine. And sorry, the alcohol here could actually be a primary, secondary, or tertiary. An amine, however, would have to be either a primary or secondary. This would not happen with tertiary amines. And we'll see why that is later. But the bottom line is tertiary amines, remember, would not have this extra hydrogen. This hydrogen has to be used in the process. Other than that, the process is the same. The hydroxyl group from the carboxylic acid will form together with an available hydrogen from the amine to form water. And the rest of the carboxylic acid and the rest of the amine come along for the ride in order to form our amide. So when we're looking at the steps of these reactions and how we would actually write them, remember an ester or a thioester are formed in the reaction of an alcohol or a thiol with a carboxylic acid. And there would have to be some sort of catalyst present, something to help the reaction to occur. The first step in these is you would want to, depending on how the compound was arranged and just how it was written, you would want to rewrite it with the carboxylic acid on the left, but write it in such a way that the OH group is going to point to the right. Then with the alcohol, write that to the right of the carboxylic acid, but write it with the alcohol group or the thiol pointing to the left. And we're going to look at some examples of this. You're then going to remove the water molecule by taking the OH off the carboxylic acid and take the H away from the alcohol or the thiol and form a single bond from where the OH and the H were removed. And so let's look at an example. And so first we're just going to look at a very generalized example of this. And so we have our R group from a carboxylic acid. So I'm just going to give myself a little bit more room to write here. And there we go. So here's our carboxylic acid. I'm just going to write my OH group in red. We're going to react that together with an alcohol. I'm going to write the H from the alcohol in red. And that's going to be attached to something else for an R group. Could be whatever. And so you can see here, again, the way that I've written this is I've got my carboxylic acid here, but I wrote it in such a way that my OH is pointing over here to the right. I've got my alcohol here, but I wrote it in such a way that the H from the hydroxyl group is over here to the left. Because, again, what we're going to see is that these are going to come together to form water as one of our products. And our new bond is going to be from this carbon onto the oxygen here from the alcohol. Those other R's, again, simply come along for the ride. And so here is our R from our carboxylic acid. The carbonyl stays the same, but now here's our new bond to the oxygen, and that whatever the other R group was coming off the alcohol also comes along for the ride. And we produce water. So there's a group transfer reaction, and what I've done is I've made an ester. So here is an esterification reaction. Let's look at an actual example now with something written in for our R groups. So let's say that I have this carboxylic acid here, and I'm going to write it. So here's my carboxylic acid. Goes to there. There's a benzene group hanging off this. Sorry, on my paper I wrote it a little bit differently, so I'm just trying to make sure that I match that up. Here's my double bond O. And here's my OH. So there's a carboxylic acid. And we're going to react that together with an alcohol. There we go. we're going to react these two together. So, like I said, in the first step, what you really want to do is redraw these so that the carboxylic acid has its alcohol. It's just easier to see it if you do it this way. So the carboxylic acid has its alcohol sort of pointing in towards the alcohol, and rewrite the alcohol so that its hydroxyl group is pointing in towards the carboxylic acid. And so I'm just going to redraw these. They're the same exact compounds. I'm just going to redraw them with that sort of orientation. So we can see there's my first one. There's my carboxylic acid. Redraw my alcohol. There. And there's my two compounds. So I just redrew them to make it easier to see what's going on here. But then it's the same exact process. These two are going to come off. And from that, this carbonyl carbon is now going to hook onto the oxygen from the alcohol in order to form my entire product now. And the rest of this still comes along for the ride. Plus my water. And there's our esterification reaction. So again, we can see that the R groups didn't change at all. This compound is still right here. This compound is still right here. Those just came along for the ride in order to form our new bond here at the ester, here at the oxygen of the ester. Thioesters would be the same thing. Again, just with the sulfur there instead of the oxygen. We see this in the formation of triglycerols in our bodies, the formation of fats. Fatty acids, which are a type of compound we will be talking about later in the course. Fatty acids, if I take 3 of these fatty acids and I get them together with a glycerol, so we can see this is our carboxylic acid group. Now picture that I have 3 of them, one here, and one here. Here's glycerol with its alcohols coming off. These fatty acids are going to hook onto the glycerol in an esterification reaction in order to make triacylglycerol. It's one of the fats in our bodies. And so there's the fat that would form. Very common reaction that happens biologically. Imidation reactions, same exact thing. You would take the same exact steps, only now we're going to have something for a carboxylic acid reacting with an amine. You'd go about it in the same way, write the compound so that the carboxylic acid has the OH group pointing over to the right, put the amine to the right of that, with the amine group pointing to the left, remove the water, form that new bond. We can see that here. So here's our carboxylic acid. Don't pay attention to the step numbers here. Those are a little different from the source that I took. But we have our carboxylic acid right here with its whatever its R group is. There's the OH. Here's the H coming off the amine. Here's our amine here. We're going to form that new bond between the carbonyl carbon and the nitrogen on the amine. So there's our new bond here to form our amide. Now note here that the amine, as I mentioned earlier, does have to be a primary or secondary amine, because a tertiary amine isn't going to have a hydrogen available here. And so the reaction would not be able to occur. Here's just an example of one. Here we have a carboxylic acid. Here we have a secondary amine. And we can see lots of different stuff going on here. But remember, the important part is that these don't change. The only thing that's really happening here is that this water is being removed, the OH from our carboxylic acid and the H from our amine here. Those get kicked out to make water, and we form this new bond right here. So this looks pretty nasty and complicated. This looks like something that's coming way out of left field, and oh my God, Professor Staples, you're throwing this weird thing at us. What the heck are you doing? It's not nearly as complicated as it looks when you boil it down to the very essence of what's happening. And that very essence in these group transfer reactions is simply that we're taking out the OH from one molecule and the H from another. Those are going to come together to make water. Oops, sorry. And in that process, in that process, when those are removed, we form a new bond here, and everything else just comes along for the ride. Everything else just stays attached as is. The chemistry, what is actually going on chemically, is happening here at the OH and here at the H for the N on the amide. Everything else just comes along. Nothing else is going to change. And those are group transfer reactions. In the next video, we're going to look at the opposite, basically taking esters or amides and breaking them apart into their carboxylic acids or amines. I thought about keeping them together as one video, but I think it's best if we do keep them separate. And so until you see me again, you stay classy, USM.